Okay, let me open the webinar. Welcome to everybody. This webinar is called How to Approach Stranded Assets When Renewable Electricity Outcompetes Conventional Generation, which is obviously something we're beginning to see happening in a number of countries around the world and is very likely to accelerate. So we have three panelists here today to talk about various aspects of that, and I'll introduce them in a moment. Meanwhile, for people who've just joined, if you could let us know through the chat box at the bottom of the screen who you are and where you're connected from. This is a very current live topic. We're seeing more and more in the news and in discussions and in conferences and in boardrooms about how some assets are becoming existing assets in the electricity sector are becoming uneconomic or financially unviable because something cheaper has come along in the form of various types of renewable electricity, or might come along very soon. And so when somebody's thinking about making a 25 or 30 year investment, they need to think very much about whether that investment will stay economic and yield its expected rate of return over that lifetime. My name is Jonathan Walters. I'm an energy economist. Energy economist particularly focused these days on renewable energy and how that's affecting policy and regulation in electricity. And we have three very good panelists, very expert in this area to talk to you about it. We have Laura Gutierrez from the International Renewable Energy Agency, Jean-François Mercure from the Radboud University in the Netherlands, and Peter Ericsson from the Stockholm Environment Institute. And I'll ask each of them in turn, when they make their presentations, possibly introduce themselves in more detail. Just to let you know that you will receive a few days after the webinar all the materials from the webinar, but also to let you know now that if you have questions as you hear the presenters speak, there is a Q&A box that you will find near the chat box at the bottom of the screen, and you can send in questions as you think of them. Please say in the Q&A box if you're directing your question to a particular presenter or to all the presenters. If you want to say something about what organization you're from, if you're from an organization, or what country you're from, that could be helpful to the presenters to answer your question. So let me now start with Peter Ericsson to present first, and Peter will introduce himself briefly and then present for maybe 7 or 8 minutes or so. Each of the presenters will present, and then we'll have a discussion time at the end. But meanwhile, please send in those questions. Peter. Peter, I think you need to unmute your microphone.
I was just doing that. All right, hello everyone, glad to be here. My name is Peter Ericsson. I'm with the Stockholm Environment Institute. I work out of what we call our US center, our US office, which is really 3 different offices. I'm in Seattle, Washington in the US, where I am a senior scientist and I lead our climate policy program here. I've been here for about a decade. Lots of my experience and background has been in carbon markets, more recently looking at fossil fuel markets and the fossil fuel economy. So I'm going to present some sort of general concepts around stranded assets that I hope can set the stage for our conversation today, as well as talk about some specific research that we've done on ways to look at this question, both from the perspective of stranding, but also the flip side of stranding, which is carbon lock-in. I'll explain that a bit more in a minute. So, you know, as I was thinking about what to talk about in this presentation, it occurred to me that not everyone uses the same definition of a stranded asset or of stranding, right? So I think I've heard maybe two main definitions, and I've put those on the screen here. One relates to essentially to money, financial stranding, and the other relates to the simple operation of an asset like a power plant. So financial stranding occurs when a particular asset no longer meets its expected or needed rate of return. This is what Jonathan referenced at the beginning of the webinar. And this is of particular interest to investors. Obviously, if they're not meeting the return they expected, that is a concern for them. May also be of some concern for operators, but in many cases, the operation of the plant can continue as long as it's covering its ongoing cash costs, its operating costs, O&M, its fuel costs. Physical stranding, on the other hand, I'm going to use that term to refer to assets that are actually physically retired, shut down, and no longer operating. And I'm going to talk a little bit about both of these concepts as we talk about the power sector today. Next slide. Okay, so the first point is that financial stranding is already happening. Especially for coal plants, as in this slide. This is data from the International Energy Agency that was organized by a group called Carbon Brief. And this purple line in particular that starts high here about a decade ago and goes strongly down towards the present is the load factor, average load factor of coal power plants. And what we see is that, it was 64, 65% a decade ago, and it's plummeted continuously to about where it's about 50% today. That's been mostly due to essentially an overbuilding of coal power plant capacity, but where that load factor has really steepened in its decline in the recent years, it's also been because actual generation and utilization of coal power plants has even declined. So, with utilization comes perhaps decreased profitability and this idea of financial stranding. Now, physical stranding, the other type, is also happening. We're in a situation now where retirements of coal plants may actually outweigh new additions of coal power plants within the next few years. This chart on the left, again, put together by Carbon Brief, this time based on data from the Global Coal Plant Tracker, shows that as we see new additions of coal power plants in China in particular have been steadily declining for the last decade, while global retirements have actually been increasing. And so the net, this black line, has been going continuously down and may turn to the negative in the next few years. In other words, more coal plants will be shut down than will be being built. So, the question very much to the point in the title of this webinar is, how to deal with this declining profitability of power plants, especially relative to alternatives like renewables. What and when to strand or retire fossil fuel power plants. As I'm sure many folks on the call are familiar with, a common and very important technique is discounted cash flow analysis using standard usual factors such as OPEX and CAPEX. Other factors that you may want to consider in that are things like real or shadow carbon price, and others may be potentially regulatory risks, such as due to other pollutants. For example, in the US, we've seen that the cost of retrofitting old coal-fired power plants to comply with important and stringent pollution control requirements related to mercury or to NOx or SOx has been so high that is a factor in a switch away from coal power as well. There may be other factors, financial factors, subsidies for renewables, or in some cases for fossil fuel power that you may need to consider also. And then stepping back a bit, it's perhaps important to think about the consistency and commitment to the Paris climate goals, both that your companies or institutions have, as well as much more broadly in the countries in which you operate. We'll get into that climate angle a bit in a minute, but it's important to state that, you know, right now we're in a situation where cost alone may be reason enough to retire coal and even gas-fired power plants, because increasingly the all-in costs of building new renewables, solar and wind, for example, in this chart, these two upper red circles are in many places even competing with the ongoing operations and maintenance and fuel costs of fossil fuel power plants. Now, there's plenty of exceptions to that. And of course, there are other considerations such as intermittency, but even the cost of storage for renewables, maybe it's 120 or so megawatt hours per 120 US dollars per megawatt hour at the time. It's dropping rapidly. That may be able to compete with, you know, gas-fired peaking capacity even in the near future. And then there is the climate imperative of meeting the globally agreed goal of 2 or striving for a 1.5 degree pathway that would have coal power phasing out essentially immediately, even considering the potential for CCS that is, you know, still a long ways off. That's carbon capture, still a long ways off, as we know. So, you know, one of the last but most meatiest things I'll leave you with here is this really deep dive analysis that we did a few years ago on putting together a way to look at carbon lock-in, which is sort of the flip side of stranding, right? Carbon lock-in is when an asset is not stranded and continues to keep going, making it harder to reach those climate goals. And what we found, if you look at these two big bubbles, the biggest bubbles here labeled gas and coal in red, are really where there's a plan, you know, overbuilding of coal, as we talked about, but also gas power plants relative to climate goals. That means that these kinds of assets may be most subject to stranding, and indeed, because coal and gas fired power plants are on the lowest part of this chart, they are most vulnerable to carbon pricing actually shutting them down compared to renewable power. So this looks across all sectors and says that indeed coal and gas power are perhaps most at risk of stranding. I think we'll hear some different perspectives on that later in this webinar that looks also across sectors. And so lastly, you know, don't wait too long to make these decisions and consider this, because as we see in many areas of the world, this is for the EU, the profitability, you know, many fossil fuel power plants, coal here is the example, are no longer profitable today. So that increases the imperative and the rationale for making the switch. That's the end of my presentation and my time. Thank you for your attention, and happy to take questions at the end of the session, or here's my contact info.
Thank you very much, Peter. That was very informative. So I would encourage people to start thinking about questions to send in through the Q&A box, and send them as soon as you're ready. Let me put a question to you that you can consider and then maybe respond to in the discussion time at the end of the 3 presentations. My question is that you know, you've talked about certain generation assets that are relatively likely to become stranded. I mean, coal and also gas-fired generation. Obviously, people out in industry, investment decision makers, can be very good at assessing those risks and taking them into account in their investment decisions, or they can be not so good at doing it. If I could ask you a sort of rather difficult question, if you had to sort of give a score, like a, points out of 10, one number, your impression of how well industry is doing in terms of that investment decision making. I mean, obviously, if they were doing it perfectly, it would be a 10 out of 10. But your impression of kind of where industry is now in terms of the new investment decisions that are currently being made. I mean, a decision made some years ago, well, okay, the information was different at that point, but decisions being made now, how many points out of 10 would you give industry? It's something to think about and to answer when we come to the discussion time. Can I now turn to Laura Gutierrez? Laura, please, briefly say a little bit about yourself and then give us your presentation.
Yes, hello everybody. Thank you, Jonathan, for the introduction. I'm sharing my slides. I hope that's already on your screens. Well, on my side, I'm an energy analyst. I have been doing work mostly on power sector regulation, and more recently in the last 3 years on energy scenario analysis. Currently in the International Renewable Energy Agency as part of a program that is called REMAP, which is IRENA's Renewable Energy Roadmap. And under this work, what we do is that we do energy analysis and energy scenarios which have a high renewable energy uptake. And one of our main lines of work is focused on global studies. And recently we have had our 2 last global studies focused on the year 2050 with the objective of meeting the Paris Agreement. The starting point of our analysis, as compared to other energy scenarios from other institutions, we don't do modeling for the reference case, but we do rather a collection and aggregation of the plans that countries have on how they see their energy sectors evolving in the future. So when we have a Paris Agreement as the objective of the analysis, what this means in practical terms is that there is a limit on the maximum emissions we could put in the atmosphere, which is typically called the carbon budget. And this is some reference that is used in this type of analysis to know what is the maximum amount of emissions we can have from the energy sector. In this most recent study, what we observe is, this is a graph resulting from this analysis. When we aggregate all the existing energy plans, which already include renewable energy targets and climate targets like the NDCs, what we see is that the resulting amount of emissions, which is shown in the upper line, which is like kind of orange here, puts us on more or less emissions on the side of sorry, this one. 1,230 gigatons of CO2, when actually the carbon budget that we have, which puts us on the path to meet Paris Agreement, is 790 gigatons. What we do then with our analysis is that we create a scenario which we call the REMAP case scenario, and with a mix of measures that encompass renewable energy additions, electrification of end-use sectors, and also further improvements on energy efficiency and other measures like carbon capture and storage for energy-intensive industries. We come up with a scenario that has significantly reduced emissions, and this is shown with the line in green in this graph. And in this way, we can be on a path which is in line with Paris Agreement. Of course, this entails a lot of changes in the way we consume and produce energy. So here on the graph on the left, we have the resulting energy mix and how we can see that is evolving from recent years until 2050. And as you can see, there is a significant increase on the use of electricity and also a bit of a change on the way we use fossil fuels. So basically what this means is we have a significant reduction on the demand of fossil fuels. We will need much less coal, oil, and natural gas for all energy sectors. This of course includes transport, industry, buildings, and also the generation part for electricity and district heating. And from this, only looking from a perspective of what are the climate policies that would come into place to meet the Paris Agreement, then we have some resulting stranded assets. This is a bit of a different perspective to what Peter was explaining. So you can have, of course, different situations for which your assets could become stranded. There may be some market situations or market drivers to it, but in our analysis, we are looking at it only from a climate perspective. So we are not further assessing anything else on terms of competitiveness, market conditions, etc. So taking an example from the power sector, what we can see here is that if we take the non-depreciated value of existing power plants that would have to stop operating before the end of their technical lifetime, we can come up with a calculation of the resulting stranded assets by the different types of technology fuel use that we have currently in the system towards 2050. One of the things that you can note here is that in our analysis, most of stranding is going to happen for coal power plants. But as Peter was saying, there is of course some gas and also some oil. And this depends a lot on the ambitions and the starting points of different countries. Some countries have more ambitions in terms of their climate policies and some others not so much. So that will differ, of course, a lot from country to country. It is not surprising also to know that almost half of these stranded assets in the power sector is China, because they have had a very rapidly increasing energy demand in the coming years, a lot of energy industry development, and they have had to build a lot of fossil fuel power plants. So there is a lot of stranding resulting from that. One of the main findings that we have in our study overall, as you can see here on the left-hand side, we have something that we call the remap case, which means that we start taking action to be in line with the Paris Agreement as of yesterday. And this means that we very soon start phasing out some of our coal, gas, and oil power plants. And this would result in a total of 946 billion stranded assets. This, of course, changes depending on the lifetime that you consider. This is not related to whether the power plant recover its investments or not. So it's not financial stranding as Peter was explaining. It's only referred to the lifetime of the stranded assets. What is very interesting to notice is that if we take no action today and we just wait until 2030 to start phasing out coal, the amount of stranded assets that the world will face are significantly higher. And this is more or less the overall results that we have for the power sector. And this is, in a nutshell, the results that we have for other sectors, which are power, because the core of our analysis is this energy scenario. So therefore, we are estimating stranded assets for all the other sectors. And as you can see, power is actually not the highest one. We have a lot of stranded assets in upstream, so everything that has to do with production, refining, distribution of fossil fuels. Also in buildings, from early renovation of buildings, from energy efficiency measures, and also replacement of components or equipment at an earlier lifetime. The bad news about our analysis is that if Paris Agreement is to be enforced and in the absence of negative emission technologies, we see that it's going to be very difficult for us to avoid to have certain amount of stranded assets if we really are to achieve Paris Agreement. And the good news is that if we started acting as soon as possible, we could significantly reduce the value stranded from all these policy measures that would come into place. I won't enter too much more into the details of this, but you have a lot of material on the website, and perhaps we have more time for the discussion. And overall, a few conclusions from our analysis are, well, in general, what I just said, like it's very important to start acting as soon as possible from a world and society perspective point of view, given that we have a reduced carbon budget that cannot be extended. At least this is the assumption in the absence of negative emission technologies. Perhaps we can discuss more about what that implies in the discussion. It's very important to start taking action soon. It's very important to consider that there will be assets stranding not only in the power sector and upstream sector, but also in industry and buildings, which are actually very significant. And there is also the need to understand what policymakers, regulators, financial institutions, and society as a whole needs to start implementing in order to avoid to have the carbon locking that Peter was mentioning, and to try to have as the lowest possible of asset stranding in the coming years.
Okay, thank you very much, Laura. So I'm seeing that people are starting to send questions through the Q&A box, so the presenters probably want to start looking at those and thinking of answers. One question I have, Laura, is, again, it's a slightly difficult question. So my sense is that there are two sorts of investors out there. There's a kind of investor that says, Paris Agreement, climate change policy, when it really starts to hit me, I'll change my behavior, I'll change my investment decisions, but maybe it hasn't really hit me yet, and so I'll just kind of wait and see. And then there's another type of investor that says, okay, I've weighed up the probabilities that policies are going to affect me, so I want to get ahead of those policies. I will get competitive advantage, or I'll be able to limit the value of my assets that are eventually stranded if I anticipate policy change and I get ahead. If you were faced with an audience that was a mixture of those type of investors, the kind of wait and see type, and the other type, the kind of let's get ahead of the curve, what kind of messages would you give to that kind of audience? So maybe if you think about that and respond to it in the discussion time. And let me turn now to Jean-Francois for your presentation. And meanwhile, let me encourage again people to send in questions in the Q&A box. I'm seeing the number increasing, and as I look at the bottom of my screen, so please keep sending them. Jean-Francois.
Hear me? Yeah, okay. Sorry for the delay. Okay, so I'm going to talk about stranded assets in a slightly more general perspective, as has been mentioned before, because the work we did concerned more than just the electricity sector. In fact, I'm going to talk about this part of the stranded assets, which is the carbon itself and the upstream assets that can get stranded. Now, the question we asked ourselves effectively was, if there is a transformation of technology that consumes fossil fuels, the demand change, how is this going to affect the various countries that produce fossil fuels or that could consume fossil fuels across the world? So we produced this study recently called Macroeconomic Impacts of Stranded Fossil Fuel Assets. Now you can see the team here. There's myself as assistant professor at Radboud University, and my colleagues who are at Cambridge University, Cambridge Econometrics, the Open University in the UK, and Cambridge University. Yeah. Oh. Apparently my volume is too weak. Is it not loud enough? Okay, so sorry for that, but I don't know how to change the volume.
I think it's okay.
All right, okay. I'll just speak nearer to the microphone. Okay, so here's the study we produced in Nature Climate Change. So that's come out recently, and it's attracted quite a lot of attention. If you look at the various newspapers, all the newspapers in the UK covered that. And they entitled the study, "Carbon Bubble Could Cost Global Economy Trillions." Now that sounds very dramatic, but I'll explain why. The context of this, okay, so here's the Guardian article. The context of this started when the governor of the Bank of England gave this speech concerning the impacts of climate change and climate policy to the financial sector, or the UK's insurance sector, and it started a whole debate, and that's been very important. Later, some study came out by these people, Stefano Battistone, who quantified what might be the value at risk from climate change and climate policy across the world. And the numbers are, I won't go through them, but they're staggering. They are in the trillions of dollars. And that's just the EU and the USA. This is important because if there was to be a realization suddenly in the financial sector that the value of these assets is not what people thought it was, there could be a rapid devaluation. And we know what rapid devaluations do to the economy, because the best reference we have is to go back to 2008, to the financial crisis, and look at how it happened then. And there was a loss in the subprime mortgage markets of $250 billion, which led to over 5 trillion of loss in the real economy, but also over 25 trillion of losses in the valuation of companies around the world. Now, this is very important. The question is, what is the impact of the current technological trajectory on the value of fossil fuels and fossil fuel companies around the world? Okay, so what we did was to simulate the evolution of technology according to what is observed as technological trajectories in the most important fossil fuel demander sectors of the global economy, and also emitters of greenhouse gas emissions. And if you want to know more about the methodology, please ask questions, because I don't have time to explain it. But we look at the power generation sector, we looked at the transport sector, and we looked at household heating. I should just mention that transportation is overly represented disproportionately because the value of oil in dollars tends to be higher per unit energy. Now, we created scenarios. We've got 3 scenarios, and I'll try to make this simple. We used a scenario from the International Energy Agency as being a scenario upon which investors might rely when making their investment decisions. I think this would be quite reasonable to think this is what they might look up first. Then we looked at the current trajectory of technology, and here I only show power generation and transportation. in two scenarios. One is the current trajectory, and one is a trajectory that could lead to achieving the Paris Agreement in terms of emissions. In the observed trajectory, we already see transformations that lead to reductions of demand for fossil fuels, in particular because electric vehicles are already diffusing and renewables as well. What does that do to the consumption of fossil fuels? Effectively, in the expected scenario of the IEA, it's business as usual, it grows. But in the current trajectory, what we saw, according to our projections, was a peaking in the demand for oil because electric vehicles are already arriving at a certain point for 2050. And that leads to quite large changes in production of fossil fuels. Of course, in a 2-degree scenario, as we expect, it's even more pronounced. So in A, you've got the demand for these fuels, and in B, you've got the production loss per different regions of the world. Now, two things could happen because there's a power balance around the world in fossil fuel markets. Those who own low-cost production assets, for example, in the Middle East, could decide not to change their quota of production as the demand declines, which would mean that they would acquire an increasing share of the market, and that is not an unlikely scenario, but they also might decide not to. And here I show in C and D marginal costs of production of fossil fuels, which take a bit of a plunge, especially for oil, as the demand changes. And that comes about because some types of production like tar sands become unprofitable. And that has enormous impacts on economies because some economies have the production of fossil fuels taking a substantial component. I have to say here, it's important to remember that it's not just directly the production that contributes to GDP, but it's also all the industries that depend from it through the supply chain, and this could lead to large changes. America and Canada are particularly hit, while the importer countries gain slightly. Now, we looked at the change in value of these assets. Now, you've got in the color bar, blue, red, and yellow, the losses of value of the fossil fuels, and the large blue bars are the change in GDP cumulated. And this is all cumulated to 2035, discounted by a 10% discount rate. And we see globally a loss of 1 to 4 trillion. That's when it's discounted. If it's not discounted, it's about 6 to 12 trillion up to 2035. Now, these numbers are staggering, and they compare to what we saw during the last financial crisis. Of course, it's not the same type of assets, so we're not making a prediction here necessarily. And finally, we asked the question whether this problem could be avoided by pulling out of the Paris Agreement. And that's probably one of the first questions that comes to people's mind. And it turns out that it's slightly worse if a country like America pulls out of Paris, perhaps hoping to avoid a loss of a fossil fuel sector. But what is the reason for that? And here I'll summarize it very quickly, short of time. If a country is an importer, importers do well by remaining in Paris because they benefit from investment in new technology and the development of new firms. But they also reduce their expensive fossil fuel imports and redress their trade balance. So that's easy to, that's sort of obvious. Now, high-cost producers like USA and Canada, they are in a peculiar situation. They have the choice. Now, if they remain in the Paris Agreement, they may lose their fossil fuel industry, but they still benefit from investments in the new technologies. But if they pull out of the Paris Agreement, they may still lose their fossil fuel industry because it's possible that lower cost producers increase their share. In other words, if we don't need as much oil, it's possible that the more expensive types of production are the ones that are stranded, not the Middle East. Meanwhile, we don't get the bonus from investing in low carbon technology, so we don't develop new industry. But because we don't change technology, we still consume lots of fossil fuels, and we may produce them ourselves, or perhaps they actually start to come from the Middle East, which is cheaper because we are uncompetitive. And so this is a triple loss, if you like. So that is why, that gives the explanation of why pulling out of Paris is not a solution to this question of stranding. Stranded assets means lots of people potentially going unemployed who work in these industries. So it really means redressing, changing the economy towards something that is where people are occupied doing, producing different types of products. And we just have to think that perhaps producing fossil fuels is something of the past, and we have to look towards the future as what is the new industry that's coming. So I'll be very happy to take questions. I think just a word about what we want to do next is it's going to be important to think about the stability of the global financial system in terms of how orderly this transition could be as it takes place, as we think, at least our team thinks, that this is a bit of an unavoidable transformation that's going to be happening. Thank you very much.
Okay, Jean-Francois, thank you very much. It's a very interesting presentation. So I see a number of questions have come in through the Q&A box. One that I think is particularly topical and relates closely to Jean-Francois' presentation, actually. There's a question about, what about the employment impact as assets become stranded? What happens to employment if the renewable energy industry doesn't create as many jobs as are lost in the stranded assets? And of course, that's debatable. I mean, it's going to be different in different places. But can I ask each of the presenters, maybe starting with Jean-Francois, because you mentioned some of those macroeconomic impacts. What's your reaction to that question about employment and unemployment as some assets get stranded and are replaced by renewable energy?
Right. Okay. So this is the big question for policymakers. Always, employment is always the biggest question. People want to know what's going to happen to people in their countries and their constituencies. Therefore, I do think it's one of the most important questions. Now, here, employment, we're talking about people who work in the fossil fuel sector, as well as the dependent industries. And as there's a lack of demand, many of these industries could lose their business. Now, the question is going to be, how possible is it that we can find these people jobs in the new industries that are developing? Because this is a painful type of structural change in the economy. And I don't claim to have the answer, because that involves studying skills and the distribution of skills across the economy, and how flexible industries are, and how we can really transform and recycle what we've got already. For example, we're asking a question such as, is Shell as a company able to transform itself to embrace the new low carbon economy, or is it not going to be able to do that and have to downscale until it's unable to operate anymore? And that's an open question. I think policymakers have a lot to do there, I think, to incentivize this transformation to be orderly. But what is more dangerous, I think, is if the transition happens a bit more suddenly through a financial sector reaction or panic. And that's where the rapid loss in investment, there would be not much solution in the short term to replace this. So I think we have to look at two areas. We have to look at the sector itself, and also how it's financed through the financial sector, and how orderly the transition takes place.
Okay, thank you. Maybe if I could ask Laura and then Peter to both react to that question about employment.
Yeah, I think actually based on the on the energy scenarios that we have, which are like the core of our work, we actually have a positive, net positive employment numbers on the estimates that we have, despite the fact that we will have many assets on the conventional side that will have to stop operating. According to our estimates, we see that actually we can have a net positive. It's actually quite low at the global level, around 0.2% of net positive employment if we are on a path that puts us as we estimate in the remap analysis. One of the challenges, well, two of the challenges that we have with that is that this net positive employment is at global level, but we see actually a lot of differences among regions and countries. What this means is that actually, given the intensive investments that you see in some countries in fossil fuels, you will have greater job losses than in some countries which do not rely so much on fossil fuels. So actually one of the challenges is how to find a way to also cooperate among countries and regions to try to balance for this. And I think very importantly also on what Jean-François was saying is that there is a need to find ways to try to absorb as many people that are in the conventional fuel field and retrain these people and give an ordered structure to the way they can actually integrate in the new markets of renewables or any other industry. But I think the renewable energy industry has the capacity to absorb many of the talent and work that is currently happening in the fossil fuel industry. I think the greatest challenge is when you have these big disparities among a country that is very dependent on fossil fuels and that does not have a lot of experience or know-how with new technologies.
Okay, thank you. And of course, even within a country, you can have a very difficult political problem when there's an industry that's shrinking, its assets are being stranded, and the people who are losing their jobs in that industry are understandably extremely upset and angry about that fact. Yeah. And even if there's another industry, renewable energy, where employment is expanding, the people who are getting jobs in the new industry will be happy, but they may not be as happy as the other people are angry and upset. So politically, you could find the people who are losing their jobs will vote around that issue or undertake other political activity around that issue. The people who are gaining jobs in the expanding industries, they may not even identify that there's some political reason to it. And so, they may not counterbalance the other people's votes. So yeah, you can get a lot of resistance to change. Peter, would you like to react on this issue of employment?
Sure. I think, as Laura points out, there's reason to think that a low carbon transition is actually a net positive for jobs and employment. And as Jean-François pointed out, let's not assume that the companies, Shell or whoever, can't reimagine themselves to keep these people employed in other ways. I guess I'd like to dig into that question a little bit and just put out an example of the oil sands in Canada, where this is a deposit, a sector that is often talked about with regards to stranding. And by the industry's own estimates, there's something like 200 billion Canadian dollars worth of cleanup to be done in the sector. And who else would be very well suited via their skills and expertise to contribute to that? So many years worth of employment ahead, potentially, even for professionals, very technically oriented professionals in these fields, to essentially clean up the legacy these industries, and that's something that, you know, could well happen as well.
Okay, thank you. Would any of the panelists like to respond to some of the questions that you're seeing in the Q&A box? Who would like to go first on that, or respond to the couple of questions that I asked? But there are half a dozen questions in the Q&A box, one of which was the employment question, but there are others. Somebody would like to go first, or maybe respond to the questions that I posed. I posed one to Peter and one to Laura at the end of your presentations. The one to Peter about scoring how well investors are doing, and the one to Laura about messages you would give to audiences that included people who investors who wanted to kind of wait and see whether to respond to climate change policy.
Well,
okay.
maybe I can start very quickly with a small comment on a question from Jorge Montalvo on what are the technologies and overall considerations that we take on the analysis. He's asking specifically about wind and solar plus battery storage. Actually, one of the challenges of producing such a scenario, which is in line with Paris Agreement, is that we need to be very ambitious on the integration of all renewable energy technologies. So, of course, actually, exactly as he mentions, we have a country-based analysis, which is also based on different technology options for the different sectors. So, indeed, wind, solar technologies, and battery storage are part of our analysis and considerations to decarbonize the energy sector. And actually, I think the question on our side is a bit the opposite. The question is, the objective is we need to meet Paris Agreement, and then we need to find ways so that policy making is directed towards that. Because even if, for instance, in the case of what he mentions in Latin America, you may see some reluctance or lack of incentives to integrate this type of technologies, we also see that cost competitiveness is rapidly increasing for renewable energy technologies. Storage costs are also rapidly falling down. So we hope that the competitiveness of these technologies versus conventional is going to keep having a very good business case. And having these as a basis for our analysis that we need to meet Paris Agreement, we don't have anything but to hope that all policymakers would be committed to take the necessary actions towards that. If any other questions come up on terms of how we assess these technology options and what are other considerations we are taking on that, my contact details are on the presentation, so we can always talk further on that and share more data, our assumptions, and further analysis. Then on the question from your side, Jonathan, I think investors at the end of the day, between the difference of wait and see and policy changes considered in advance, I think at the end of the day, if we're talking purely about investors, investors care about having a good return on their investments and having certainty on the decisions they take. And I think what I find really key is for investors not to overlook the opportunities that renewable energy, energy efficiency, electrification, and all the energy transformation is bringing to the business. But also I think it's impossible to get where we want to get if we take into consideration climate objectives without further policy measures. At the end of the day, investors are only going to go to take a path that is somehow, something that gives a benefit for them. So if renewables are giving them a benefit, this is, of course, a good way to go. And I think what we need is stronger signals from policymakers, and also very important from financial institutions, like Jean-François was saying. Bank of England, I think, is one of the actors that is very much investigating this issue, because there are a lot of financial models and financial stability that does not consider long-term impacts, such as climate impacts on decision of investments. And I think there's a lot of need for people to be aware and create the appropriate regulations and incentives for the private sector to take the right decisions.
Okay, great. Peter, did you want to respond?
Sure. You maybe I'll pile on that to answer your question. Was you gave me this sort of cheeky question of rating the investors on a scale of 1 to 10 and how they're doing in regards to stranded assets. And I thought about that a little bit, and I think I'll rate them a 4, because there's still quite a lot of new investments in coal power, as I think slide 4 of my presentation showed. And that signals to me that despite the fact that there are very competitive investments in renewables to make instead, despite the fact that many coal power plants are not profitable, and despite the climate imperative, that there's still a large number of coal plants being built, that doesn't add up, I think. And so that's where I challenge investors to really rethink those, as many others are already doing. That's why don't give it a 0. There's a 4. It's a 4. Plenty of investors are seeing the light, seeing the writing on the wall that coal is no longer a good investment.
Okay, thank you. Interesting you say it's a 4, because I had in my head a 3. So so we're close. I mean, some people are doing something, but a lot of people are not seeing the writing on the wall. My personal view. I think it's like a lot of people investing in horses when cars were just about to take over. But let's see. I'd also suggest that because for some years the dialogue has been very much about climate change and about policy, and yet actual policy has mostly not really been strong enough to achieve the climate change goals. You've had some investors, perhaps many investors, who've been focusing on the lack of strength of climate policy, and a little bit missing what's actually going on in the market and what's going on with trends in cost, and not seeing that the market is going to outcompete them, even if policy doesn't put them out of business. On that note, I think we need to conclude. We've reached our time limit. I think it's something we could probably go on discussing for many hours, but we have reached the time limit. So let me thank all our presenters for their excellent presentations, and thank all our participants for participating and for sending in questions. Thank you very much to everybody. And let me also just remind everybody that the webinar materials will be made available to everybody who registered a few days from now. Thanks.
Thank you. Have a good day.